Okay, good afternoon. Welcome to
Math number 1080.
1080. So we got another Catriona Shearer puzzle today, and actually we're doing something completely different this time. Here we have not even looked at the Twitter thread to see if you have the right answer.
Yes.
So we are going to present this, and then we're going to go check the thread and see what we see.
Okay.
All right, so this is from April 13th, so call it about a month ago. Both colored regions have area 10. What is the total area of the two rectangles? Oh, very interesting.
Okay.
All right, so what'd you find?
Alright, so first I started by labeling sides.
Okay.
I labeled this long side as x, and then this as 20 over x.
All right.
Because they multiply together to be 10. Then what you can see is that this length here is also x.
Okay. Yep, I see that.
And
but explain why. That's a good observation.
because these two triangles have the same base.
Okay.
And if they have the same area, they also have to have the same height.
Good, great,
And the height
fantastic.
goes from here to here.
Okay.
Then, since these two straight lines are intersecting, that means these two angles are the same. And since this is a right angle, this is a rectangle. That means these two triangles are similar, and since they have
Wait, which two angles have to be the same?
this angle and this angle have to be the same. Here and here. Go at like
Oh, this angle doesn't have anything to do with this pencil line. It's all the way up to here, right?
yeah.
I see. Okay, yeah.
Here.
Sorry, I misunderstood. Okay, got it. Yep.
Then here, this is a right angle because of the rectangle.
Okay.
That means these two last angles have to be the same.
Yep. Got it.
So the triangles are similar, and because they each have a leg with length x, they are congruent.
Okay, got it.
That means that this point here splits the side in half, so this is also 20 over x. And that means we can put 4 of these triangles inside the big rectangle for a total area of 40. But
Okay.
it's just for the big rectangle. Now we have to do the small rectangle.
Okay, super. Oh, that's a great observation.
So let's see. So similarly here, this angle and this angle are the same because these two lines are parallel.
Okay.
So we have another similar triangle. And this, we can sort of fold this part here, I called it A.
Okay.
We can fold it over to create this new triangle, and this sort of fills in the rectangle here, and then that makes these two triangles congruent.
Mm-hmm.
So we can put this in, these are part C, this is part A, so we have parts A, B, and C represented here, and then we just slide it over, and that makes this rectangle here.
Okay, wow, that's really nice reasoning.
So that means that total area is 40 plus 10, which is 50.
Okay. Oh, I really like that. That was really nice. So you knew this height was the same as that height, and this, when you folded it over, is down to there.
Yeah.
Okay. How did you know this length going out here is the same as this length going up here? That's the one thing I wasn't quite sure about.
Let's see. I might have just kind of involuntarily assumed it, but I guess we do have to make sure. Yeah, I guess I just assumed it,
Okay.
but yeah, I mean,
I think you can get it. I think you can see why that's true.
it is a similar setup to this triangle here.
Yep.
So we have I mean, we don't know that any of the sides are the same, really, because trying to prove that this side and this side are equal, we don't know that, and we don't know that it cuts the side in half.
Yeah, so if you can show that this length here and this length are the same, you'll have it. So that length and that length are the same, so why should that be true?
This length and this length.
Yeah, because if those two lengths are the same, this triangle will fold right on there and that'll be
Yes.
straight up there. So it is, I think it is true. Let's see if you can see why.
Well, maybe if these two rectangles are similar, and this side is half of the big rectangle side, so that means that this side is half of this side here.
Okay.
And so that would make this x over 2 and this x over 2, so then they would be the same.
All right, that's a good way to see it. And so why was that true? Why was this rectangle similar to that one? Why was it half?
You have, let's see, you have this, you have the side here, and you have a scaled down version of that triangle. That still doesn't prove that it's similar.
Well, but there is something that you definitely know is half in here. So what do you know is, you know for sure something's half. What's the segment that you know is definitely cut in half?
This segment here, this is half of this.
Okay, so think about lines going down here. So look at a big triangle involving that line. That whole segment.
This one here, or this here.
Yeah.
Here.
Okay, so that triangle. Yep, and can you see one?
So this triangle and this triangle
There you go.
are similar, and this side is half of the big side, so this is half of this.
Yeah,
It's
there you
another triangle relationship.
Yep, good job. All right, that was good. That was a very nice reasoning. That little detail at the end was important, but you got it. All right, so now let's go to the thread and see what we can see.